Hello everyone, am I audible and visible? Do let me know right now. Okay, so we'll wait for next few minutes to get some more views and then I will start. So till then you all can give your feedback what you are expecting today from this session and what do you think that this session will be all about since it's intro to machine learning and we are talking about setting up some stuffs. So any idea? Um, skill brats, since you are saying that there will be some hands-on coding session today, so I would say that this is not about coding today, but this is more about uh, giving you some insight of what should be some of the good practices that we should follow so that you do not have to worry about like all the computer science stuffs and focus more on your data science and your machine learning task. Yeah, we will be talking about Python libraries installation. So I guess I should be starting my session. There's no need to waste any more time. So I hope I am visible. My presentation is visible to all of you. If so, do let me know. Okay, so hello everyone. Today's session will be about setting up your Python environment for your machine learning task. And just to say few stuffs, whenever I will talk about or say this word ML, I would also mean DL, which is deep learning. Okay, or so whenever I will say ML, be sure that I am also talking about DL, which is also a domain of artificial intelligence, and more things will be coming on those topics. Going ahead, it's me. Like I love deep learning for my computer vision. I have some posts. I have won some competitions in the past, and I'm a human being. So love everyone. So today's agenda is to give you insight of what should be a good practice or a practice that I follow. It may not be necessary that you follow the same practice. It may not be necessary that you mm, just copy what I am doing. And there's nothing as right or wrong in today's session. This is all about preference and your choice. So this is some of the like agenda of today's talk. Like we will be talking about Anaconda and what are the tools that we have at disposal. And since this session is all about making your life easier for your machine learning task, so that you do not have to think about all the dependencies and configuring all the setups and everything, and just focus on learning the techniques of machine learning and learn the algorithms and all the cool stuffs out there which you where you can contribute or you can use that to enhance user experience or do whatever you want to. That's up to you. But in all that process, like Python or the libraries that it has should not come in between. It should not be your headache. So we'll see how we can avoid those headaches, and we'll talk about some Conda concepts and commands. So today's session will be basic. We won't go into anything deep or anything advanced because I feel that it's important that like for the beginners, it's important that they should have a good start. And trust me, the all the things that I will be speaking today have never let me down. I do not get headaches, and it has worked fine with me. I don't tend to like, since things go like work fine for me and I do not have to use advanced stuffs very often. Trust me, you will also not have to use the advanced stuffs very often. With simple commands, few line of code, you are good to go. Okay, so going with the introduction. Before getting into this topic, I just want to put out some points straight. Whatever tools that I will be talking about is something that I use. The practices will be that I follow, and there is no right and wrong that I said previously. It's my choice. There will be something which will be your choice. Today's session will be a guide. You can take bits and pieces from here and there, and you can have your own setup, your own preference. That's up to you. But I can guarantee that it will certainly help you in your ML journey, and which is the most important part. Okay, going ahead. So the first thing that we have to think about ML is ML. You may have heard that ML is all about mathematics and mm, algorithms and everything. So If ML is all about those mathematical concepts, you may have heard somewhere that neural network is like the representation of how the human brain works. So why do we require that we should have a programming language? Because obviously, if you want to train your machine, if you want to make your machine learn, you have to interact with the machine. That's the first requirement. So which programming language do you want to choose, or which programming language is the best to choose? So in my preference, Python is the way to go. There are other programming languages like R, but Python is great. Like it has everything that you require of all the worlds, all the best thing of the n number of worlds out there. You have all the power to conquer whatever you want to. So why Python for ML? Then why it's easy to screw up everything? Because obviously with great power comes great responsibility. With great power comes a lot of risk as well. And then why even bother about managing stuffs? Because obviously if you are not managing stuffs, the migraine level will be 100 or whatever this number is at some point of time. So why Python for ML? I would like to ask you all, give your idea of why you think that Python is good for ML. हेलो, फ्रंट स्क्रीन दिख रहा है और मेरा आवाज आ रहा है। हाँ, अभी भी चल रहा है। अच्छा, रुका रहा, वैसे तो दिख रहा है। ठीक है, ठीक है। ओके, फाइन। हाँ, हेलो, रख रहे हैं। ठीक है। Hello everyone. I guess my presentation was stuck at the front page and you have missed few of the slides. I guess I am visible now. Like my presentation is visible now. Okay, so I will be talking about, like I asked a question that why do we require Python for machine learning? Why we should go with Python for machine learning task? So I would like to hear from your side. Like some of you said that because it has some predefined package important for ML, that's okay. Because it has inbuilt packages fast for calculations and evaluations. Okay, easy to give instructions, has its own built-in vast libraries. Okay, that's true. Like you all are true, but there is one mistake that everyone is doing right now. Python do have a lot of cool libraries, a vast number of libraries that comes up inbuilt. But there are many libraries that Python do not have inbuilt, and you have to install them separately. Like TensorFlow, for example, is one of the most used package for deep learning and machine learning tasks. And TensorFlow do not comes inbuilt with Python, so you have to install it separately. So I said that why to even bother managing everything? So there was a meme which you all didn't see, so I am showing that again because it's very easy to screw up with your Python management, and sooner everything will just go haywire, and you will have a great headache if you do not have someone or something to support you. So we use Python for machine learning because of its simplicity. It's very easy to read code in Python. You can easily like your code are easily readable by other developers, so they can contribute in your project. They can find issues in your project. It's just great. Like it's very easy to learn the syntax of Python, and any beginner will like in a week time can get into Python and be comfortable with all the basics. Then it's platform independent. That means you can run Python on Windows, Linux, or whatever platform you have. And the best thing or the greatest thing about Python than any other language out there is that it has a great community support. There are tremendous number of packages and modules available that we can use to do our task. Like you can see in the meme that this is the simple cheating. Import is essays from like someone created a module named essay. I am importing that module and I am doing my stuff and I'm done with that. Whereas if you are using Java, I am sorry for all those who love Java, you will keep on writing and writing and writing, and someone like me will never understand. I'm sorry. Uh, Next up, let me point out some of the uh, logos that is down in this presentation. We have Keras, TensorFlow, SciPy, NumPy, Matplotlib, and Scikit-learn in order. So you can just imagine that there are n number of libraries that you can use, and it's great because for each and every library that I have mentioned right here, there is great community support, and you can find out all the problems, answers to all your problems. So what's okay? So we understood that we have to choose Python. You can go with R, that's up to you. But trust me, there's great packages like TensorFlow and Keras that you won't find in R. There are good stuffs in R as well, no denying. So ranking the Anaconda. So any guess what Anaconda is? Your idea of Anaconda. Okay, I'm going to the comments, and someone said that I missed MATLAB. I'm sorry to say, yes, I missed MATLAB, but you cannot do open source stuff with MATLAB. You must have a license, and not everyone can afford license. And MATLAB is really good with data science and stuff. but still it has some way to go to catch up with TensorFlow and Keras. I feel so. Correct me if I'm wrong. So with Python, we have something known as Python Package Manager. As I said, there are n number of modules which we can call packages. So what are packages? Packages are package is simply a directory which has a underscore underscore init underscore underscore dot py file. That's it. You can have n number of Python scripts like run this.py, draw this.py, etc. etc. And in that directory itself, if you have an init.py file, that's a package. So there can be numerous number of packages in your Python directory, and to manage that, you can either use PyPy, PyPI, which is Python package index, which is the default Python package manager by Python, or you can use Anaconda by Continuum Analytics. Continuum Analytics is the software company which developed Anaconda. Okay, so this is the download page of Continuum Analytics Anaconda. As you can see, it's clearly written that Anaconda is an open source distribution of Python and R as well for data science and machine learning work. So with just one software, you can either work with Python or R for all your data science requirement and machine learning requirement. And that's not just it. You can even fulfill all your web development requirement or your game development requirement if you are using Python for some things. If you are making GUI for using TK-inter, I am sorry to say, but yeah. So as I've been saying for last several minutes, you can use Anaconda distribution for all your Python related tasks. So I would at this point of time ask how many of you are using Anaconda, and how many of you are not? Like if you're not using Anaconda, the next step that I am gonna do is install Anaconda right now and tell you few important key things that many of us miss during our first Anaconda installation. Okay, so someone said that he has Python 3.6 installed and Carla wasn't running on 3.7. Yeah, Anaconda is amazing. So we are heading towards the installation of Anaconda right now. Okay, so you can go to your to this link, which is anaconda.com/distribution, and then you can click on download, and it will direct you to this section where you can either select for your Windows installation or your Mac OS installation or your Linux installation. Since I am on Windows system, I will be showing how to install this on Windows. I hope many of you are using Windows, so it will be useful that I show you. So click on Windows, and then you can click on download, which will simply ask you to save this executable file. You can save this file. It's some 486 MB uh, installer file. It will take maybe some time depending on the internet connection. I already have this installed in my system, and I will be going ahead with the installation. So simply double clicking on this. This is the setup wizard for the Anaconda installation. Next, I agree. See, install for just me, which is the recommended setting, and for all users. Like if you are in a connected network system, you can go for all users. But since you are installing on a local machine, click on just me and click on next. It will ask for the destination folder where you want to install your Anaconda. Since I already have this installed in the directory that is showing, I won't risk it anymore. So I will simply maybe install at some other place. You will require to have an empty directory in whatever place you want to install Anaconda, and then click on next. Okay, so now this is the most important part that I wanted to show you all, is that in the advanced option, make sure to click on add Anaconda to my path environment variable. See, it's not recommended by Anaconda, but you must do it because like it's your choice. Like if you are really good with managing your own path variables, you can leave this. But if you're not, trust me, clicking this will save a lot hell of time in the future with your machine learning task. So make sure to this to check do a checkbox. Now using this, what will happen? I will be showing you later, and you can also click on this wherein you can register Anaconda as default 3.7 so that all your code editors like Visual Studio or PyCharm will be able to recognize Anaconda as the primary distribution for Python 3.7. So all your code editors will be able to access all the libraries and the modules that you are installing using Anaconda. And then you can click install. It will take some time to install. Since I already have it installed in my system, I won't be installing this. You can install and uh, and then play around with the installation. Okay, so once installed in your system, what are the tools that we have at disposal? You have a Python package manager, which is Anaconda, in your system right now. With just few click of buttons in the setup wizard and some MB of download, you are now a step closer to being free from all the headaches that you might have faced if you do not have something like Anaconda in your system. Many of us in our initial years, what we do is we go to the basic Python installation from python.org and we install the simple plain Python ideally, and then we play around. And as we start working on complex projects, things start messing up because what happens is when you download a module, say XYZ, it will require other modules to be downloaded. It will look for other dependencies, which we call dependencies. Uh, and then a Python module may require a certain version of one of the dependency, and your another Python module, which you require for the same project, may require another version of the same dependency. So it may cause a lot of problem if you go about that doing manually. So with Anaconda, you are safe. Now let's look at what are the tools that we have at the disposal. So we have the old school Python ideally that we all know. We all may have seen this somewhere. Then Jupyter Notebook, I guess we all have seen this. The IPython, which is the interactive Python, and Anaconda Navigator, which is a cool GUI provided by Anaconda, wherein you can navigate and use all the tools and look at all the mod packages that's available and all the environments that available. It's a uh, good graphical user interface for managing your packages. So let's go through each of them one by one, and then we'll move ahead. So how will you access your Anaconda that you just installed? Simply press your Windows button, type in Anaconda, something like Anaconda prompt will pop up. Select this Anaconda prompt. You can see something like base and then the path. So the base is the base environment or the starting environment that I have. So let me show you how to open Python ideally. Simply type in ideally and it will give you a Python 3.7.1 shell. From here you can open your script, whatever script that you want to open. Say I have this script right now here, and you can press F5 and you can run this script. You can press CTRL and N together, and you will have a new untitled script. You can save this like with the name test.py. You can say print DSC NSEC intro to machine learning, and simply press F5 and you can see something coming up on your Python shell. So I personally have been using ideally for a long time. I recently shifted from ideally to a more painful way of doing stuffs, but that's the best way I feel like. So this is the Python ideally. Let's look at Jupyter Notebook, which is one of the most important tool that we have with Anaconda. You can also have Jupyter Notebook without Anaconda, but it will be a hassle. When you type in Jupyter Notebook on your Anaconda prompt, it will take a moment and it will fire up a server and will start running a Jupyter Notebook server on a local host. As you can see, I have something like this with some notebooks, some files, directories. I can go into the directory. Important stuff to show is if you click here on new and click on Python 3, you will have a untitled Jupyter notebook, and like you can give it a name, and currently where my pointer is the cell that we call in Jupyter notebook. Each cell will contain some code, and by pressing shift and enter together, you can run the code in that shell. Say print hello and shift and enter will run the code in the shell. So what's the great thing about using Jupyter Notebook? Earlier I showed you Python ideally, wherein you can write scripts. So to see the result of the script, you have to run the script every time. Suppose you have you have to load a machine learning model, a keras model or a tensorflow model, and it's heavy. So every time you are running the script or you are trying to debug something, you have some error. Every time you are running the script, you are loading those uh, TensorFlow model again and again, and it's taking up time. It's better to use Jupyter Notebook because once you load a model in your shell, it's there, and go ahead with another cell, do your editing, do your debugging, prepare a code, and whatever variables or the modules or the classes that you have in your previous cells will be available to you throughout the notebook. So you do not have to run the notebook again and again to access those variables or objects that you have created. So you can see by clicking on kernel, you can either restart the kernel and clear output. You can shut down. You can change kernel. Right now, I only have a Python 3 kernel here. You can have Python 2 kernel. You can have Python 3, Intel Python 3 kernels. That's up to you. Okay, so closing this, you can click on running and you can shut down this kernel, and you can simply close this. To close this Jupyter Notebook kernel, do a ctrl C and it will shut down the kernel. So I talked about two of the most important tools that we have at disposal, the Ideally and the Jupyter Notebook. And trust me, you will require nothing more than your Jupyter Notebook and your Ideally for your machine learning task. Now you can also have something like a VS Code or a Sublime text editor for writing scripts. That's up to you. But for all the data exploration, data analysis, preparing models, and many a times training your machine learning model, you will require a Jupyter notebook. That would be sufficient. So I hope this is helpful for you and you will be able to proceed ahead without much hassle. Okay. So how to avoid headache? So I talked about all these packages that we have, the tools that we have at disposal, and how good Python is with all the community support that it has. But still, somewhere you must be thinking that you may want to do your data science as well as your web development or some other form of development. So how to avoid the headache of maintaining all the packages? So this is where Anaconda starts showing its actual power, because you can have those tools like Python, ideally the Python shell or the Jupyter notebook. You can install them separately and you can use them. But the actual power of Anaconda start coming or start showing up when you go deeper into your project with the complexity of your project. So there's something called as environment. You may have heard this term that in Python, we create environments to keep our packages or our modules. So a Python environment manager is something which helps to create those environments, to manage those environments, and to keep the packages separately for different tasks. As you can see, as you can see that we have two different environments: a web dev environment and a data science environment. We have the packages like Django and Flask and Jinja 2 in the web dev, and we have like TensorFlow, Keras, Pandas, NumPy, etc. in the data science environment. So you must be thinking that why not have everything in the same location or in the same base place? So first and foremost, this environment is basically a directory in your local machine wherein these particular packages are installed. So as I said previously that maybe a package or a library may require you to have some dependencies which are other modules and packages, and those dependencies come with their own versions. So maybe you are working with Python 3.5, and for Python 3.5 you have a module which requires the dependency of another module, but for Python 3.7 all these versions are not the same. So having everything in one single directory or one single environment will mess up the whole thing. You will every time have to come back and configure for a required version, which is a headache, obviously. So to avoid that, we have something called Python Environment Manager. You can either use virtual env or pyenv. Now these are the environment manager which comes with which are used with pip. So you must have heard pip. Pip is the standard way of managing Python packages, and Python it's like recommend to use pip. But we also have something known as Conda. So Anaconda uses the package manager known as Conda. You must have heard of GitHub. So GitHub is the place, is the website which under the hood uses Git as the version control. So Anaconda is a distribution which under the hood uses Conda to manage all its environment and packages. So the difference. So with the help of pip, you can only install the packages and play around. It's a package manager, but you will not be able to create environments with pip. For creating environments and managing environments, you will require a virtual env or pyenv. Now this is where Anaconda shows its power. With Anaconda using Conda under the hood. Now Conda is a language agnostic. That means it do not see which language you are using. You can either use Python or R or C or C++. It can install the libraries from any of these languages. It's language agnostic and it's cross-platform. That means you do not have to worry about the platform. It's either Linux or your Windows. And Conda is both a Python environment manager and Python package manager, which pip otherwise isn't. So with pip you require virtual env, with Conda you just require Conda. So now since this whole session is all about data science, you may not require this web dev environment for your work. You will only focus on data science, but as you go ahead, you may want to play around with different versions of TensorFlow, right? Recently, we have TensorFlow 2.0, and you may have been using TensorFlow 1.13 for your development. So at that point of time, changing your base environment's TensorFlow installation, which was 1.13 point something, to TensorFlow 2.0, all the codes that you have developed using 1.13 will not work properly. It will start breaking up. So going with Conda and its concepts. So what are some of the concepts that we have in Conda? As I said, with GitHub, we have Git under the hood, controlling all the versions of all the software that been developed by n number of people. With Anaconda, we have Conda under the hood, which manage package and environment. And there's something known as Conda channels as well. So
So going on with each one at a time. So with Conda package, you have some facilities like you can install uh, the desired or required package. You can uninstall it, you can remove it, you can install a specified version of that package. With Conda environment, you can either create a new environment, you can, with just one line of command, you can activate that environment. With one line of command, you can deactivate that environment. I will be showing you these stuff in a small demo. And then channels. What are channels? Channels are basically uh, a repository somewhere from which Anaconda is downloading all these packages. So we have Conda Forge as one of the default channel that Anaconda uses under the hood. So Conda Forge is an open source uh, place wherein a lot many packages are kept, and whenever you install a package which is Conda, it looks through that repository, see whatever package that you want, it will pick that up, it will download and install in your local machine. Simple as it is. You do not have to worry about the dependencies, you don't have to worry about the versions. It will manage all on its own. And then we have some Conda commands. So we have Conda search, Conda update, install, list, and create. So I will be going through each of them one by one, and you can see how easy it is to go about your machine learning task without going having any headache. So right now I am in my base environment. I can say that because base is written right here. It may happen that base is not written here, so you can check out using conda env list. It's a command through which you can list out all the environments that you have that you have created. Okay, so two things. First, I am shown some warning that conda.compat module is depreciated because I am using an older version of conda. To update that, to update conda, I will do simply do conda update conda. Click, press enter, and then I will do something like conda update anaconda. Now, since this will take a lot of time, that's why I'm not doing it right now. Going back, I talked about the environments. So you can see there are environments like Dashboard, DSC NSEC2, DTC, face recognition, OpenCV3, Pi2 Vision, etc. So you can have n number of environments, and they all are, as I said, are directories. See, you can see the path. C uses Ayush Anaconda 3 in ENV and Dashboard. So in this particular directory, I have all the packages that I required for this particular task that I was doing some time back. And I do not have to worry about all this version matching and dependencies control and anything. I will simply activate this environment and I will go about that. I have an environment named Pi2, which is an environment wherein I have Python 2.7 because Python 3.6 or 3.5 or 3.7 is the default which we get with Anaconda. And obviously, we all use Python 3.3.x because why not? 2.7 is old. So, first, how to create a new environment? It's simple. Conda create underscore, sorry, hyphen n and say DSC NSEC. Press enter. As you can see, it's collecting package metadata, it's solving the environment, and then it asks whether I want to proceed with the installation of this package, of the packages in this environment. I will press yes, and hurrah, I have the environment named DSC NSEC. So how to activate this environment? It's simple. Conda activate DSC NSEC. And hurrah, as you can see, I am in my DSC NSEC environment. Now I can do Conda install Pi audio. Now, sometimes if someone asks me how to install Pi audio, he was having some problem with his installation, and I would like to take the opportunity to show how easy it is to install something which was hard. It will simply collect those metadata, it will solve the environment, and then it will ask for my permission to install all these packages into this particular environment. Press Y, and in some time I will have this package installed in my system. That easy. Don't know why it's taking some time. Great. So I have some other stuff that I want to show you. Like to deactivate this environment, simply type deactivate and you are back to your base environment, or you can type in conda deactivate, you'll be back to your base environment. Now if you want to see the list of packages that you have, you can simply type in conda list and it will show you all the packages that you have in that environment. Hurrah. Now suppose you want to create a new environment with some version of Python which is either lower or higher than what you are using. So you can simply do conda create and py 36. I don't know why it's taking time to execute this transaction. It usually do not take much time. And hurrah, I have this environment ready with Python 3.6. I can simply activate this environment and see when I type Python I can see it's Python 3.6.9, whereas in my base environment I, okay, I didn't deactivate, whereas in my base environment I have Python 3.7.1, and thus you can play around with different versions of Python and have your packages installed, and it is so easy. At times when you are building a project you may want to uh, like in your GitHub repositories README file, you may want to list all the Python packages that you have that one require to run your software or your project. You can simply have a requirement.txt file. You may have seen requirement.txt file there. It's easy to get the requirement.txt file out with whatever environment you are using in. Say if I'm in my base environment, I can simply do conda list export requirement.txt and it has created a requirement.txt file. Uh, I'm not able to find that right now, but it's there in your user profile, wherever your user profile is, see users are used, there will be a requirement.txt file, and you can simply put it on your repo and someone can use that. You can also install the packages from that requirement file by simply doing conda install file and then requirement.txt. Simple as that. So these are some of the ways that through which you are through which you can really get rid of the headache. One last thing that I want to say here is, like with Anaconda, you can use Conda as much as you want, but at times, like since many of us, when we start our development in Python, we usually use pip. So with Anaconda, you can also use pip. So nothing to worry. But just a warning, with pip do not looks at all these, like pip do not care much about managing the dependencies. With Anaconda, it's surely fast, but with Conda, you are foolproof that nothing is gonna get screwed. So that's some of the commands that I talked about. You can go through there, the Conda documentation page. You can go through the Conda documentation page and you can have the list of commands under the command reference. You can have Conda clean, Conda config, create, info, install, list, everything. With Conda info, you can know the install Python version and all the channels that's been used. It's the give you simple gist of whatever there is in that environment. It's a nice tool. So that's it from my side. Thank you, and I am open for questions. I guess we are almost on time. So yes, with list it shows the version of all the packages too as well, because obviously we require that. Yes, we have Anaconda available for Linux as well. Let me show you. See, in this page and at the Anaconda distribution, you can have for Windows, for Mac OS, and for Linux as well. Simply download this in your Linux system, and you're good to go. Are there any more questions that you may have? Something that I missed? Something that you want to add? Okay, so on an ending note, I would like to say that going ahead into this session, you must have Anaconda installed in your system because we all love Anaconda. It's a great distribution for Python. Uh, Work out and play around with all those Conda commands. Create your own virtual environments. Install packages in those environments, and get back to us in the WhatsApp group or in the Slack workspace with all the doubts that you have, the issues that you face. And I am sure that most of you will not face any issue with this because it's simple. and you do not have to think much. So from now on, you will be more focused on learning the machine learning algorithms, the machine learning tasks, and all the cool stuff that we'll be talking about next. So that's it from my side. So thank you everyone who was there, who stuck with me. Our next session will be on uh, intro to Python. So the next speaker will be talking about the various basic stuffs that you can do with Python. It will be like a brush up session where you will actually import those NumPy, Pandas, Matplotlib, TensorFlow, Keras, you name it. I hope my session was intuitive. I didn't show you much because there's nothing much to show. They are the simple one-line commands. I can keep on. I can open a cheat sheet. You can Google Conda cheat sheet. You can have a list of commands, and you can keep playing with that to your heart content. And I would really recommend that you do that because that will really strengthen your use of Anaconda and Conda. And that's it. Thank you. I hope you enjoyed it.